All right. So I actually got this idea from one of my questions in my assignment. Don't worry, I'm not going to use the same question that's in my assignment, but I want to explain how it's done, how this procedure is done, and hopefully this can help you out a bit. Okay. So today we're going to talk about solving. So solving logs with the same base. All right, with the same base. There's going to be a few rules you're going to need to know when we deal with this, okay? So logs with the same base, we are going to need the rule, right, of this one. So log of a of x plus log b, oh sorry, log a of y equals log a x times y. We're going to need to know this rule, log a of x minus log a of y equals log a x over y. Okay. We're also going to need this rule, log a of x equals log a of y, which all this means is x equals y. So these are the three principal rules you're going to need to know when it comes to solving logs with the same base. All right. So let's do some examples together. Again, if you want to download this, it will be down in the description. Just click on the link. It should bring you to the page. If not, let me know. Also, if there's anything you want me to work on moving forward, you can always let me know, right? So let's start off with this question. So we have log of 2. This is a simple one. Equals log of 2 of 8, right? And they ask you to solve for x. Well, you can cancel out both logs, right? Because they're both base 2. And you can now say x would equal 8. And that is your answer. All right. Let's do the next one. That's one example. Let's do another example down here. Let's say we have log base 6 of x plus 4 equals log of base 6 of 10. All right. Again, same bases, right? We're using the rule, by the way. We're going to use the one. I'm going to highlight this right here so you guys can see it. We're using this rule right here for now. We'll use the other ones in a bit, but we're using that one for now. So we're going to go back down here. Again, we can cross these off. Oh my God, that's a really bad X. Let's just do this. There you go. Cross those out. And then we can say, okay, well, X plus 4 equals 10. Because remember, they both have the same base. In this case, it's log of base 6. So X plus 4 equals 10. Move the 4 to the other side, and X equals 6. And that would be your answer for X. All right, let's do one that's a little bit harder. We're going to leave it after this example here. So hold on, example. Let me do another example here. All right, because this one's going to be a little bit harder. But anyways, we're going to do log of base 3 of x plus log of 3x minus 2 equals 2. Okay, let's say equals 4 actually. Now, what rule are we going to use here? We're going to go all the way up to our rules that we're going to need, and we're going to use the first one. Okay, we're going to use this one, which is going to be important. So we can condense. I'm going to underline it in red. We can condense these. Okay, so what we're going to do is we're going to do log of base 3 x times x minus 2. All right, which equals 4. What I underlined in red is the same as what I underlined in red over here. Okay, so now we have log of base 3 x squared minus 2x. Okay, equals 4. Now, actually, there's one more rule I forgot to add. We're going to put over here. Okay, it is now what essentially the basic log rule, which is saying log of a of b equals c is the same thing as saying a to the power of c equals b. Okay, so we're going to go down here. We're going to use that rule. So we can say with this 3 to the power of 4, right, equals x squared minus 2x. Now, 3 to the power 4 is 81. So we have 81 equals x squared minus 2x. And then from here, we can bring the 81 to the other side. So we can have 0 equals x squared minus 2x minus 81. Now I'm just going to show you one method you could go about this. Is the following. Does this have any perfect roots or perfect numbers we can use? So we do this times some number times some number will equal minus 81, and then some number plus some number will equal minus 2. Well, we know 81 is divisible by 9, right? 81 divided by 9 is just 9. We can do 81 divided by 3, which is 27. It's not going to really work out in our favor. We can do 81 divided by... No, I'm just trying to think off the top of my head. 81 divided by like what? Honestly, I have no idea. So we're going to scratch this out, and we are going to use our quadratic formula, which, if you guys remember, is x equals b, right? Yes. Oh my God, why am I blanking out on the quadratic formula? It's crazy. Anyways, minus b plus or minus square root of b squared minus 4ac, and all this over 2a. We already know in this case our a is what? Our a is 1, our b is minus 2, and our c is minus 81. So I'm going to plug this into here. So x would equal minus 81 plus or minus square root of, oh my God, it's not 81 here. It's minus 2. Sorry, my mistake. So it'd be minus 2 squared minus 4 times a, which is 1, minus 81, like that. And then we're going to go all this over 2 times a, which is 1. Okay, so the top part, let's work out each part individually. So minus 2 is plus 2. So we have 2 plus, or minus, sorry, square root. We have 4 plus. So we do 4 4 times 1 times minus 81 equals 328. So in this is 328. All this over 2. Now, is 320 a square? No, it's not. But can we do 328 divided by 4? We can, which is good. So hold on. 328 divided by 16. No, we cannot. 328 divided by, so 4 is 82, right? So this here becomes 4 and 82 times 82. You can see where I'm going with this in a sec. Actually, I'm gonna do this on the side so it's much more clear. So 328. 328 becomes the same thing as saying 4 times 82, right? And we know 4 is a perfect square. But 82 now, can we divide that by 4? No, we cannot. 82 can be divided by 2. It comes up to 41. 82 divided by, I don't know, 8. No, 82 divided by, oh, why did I say 8? 82 divided by, let's say, 6. Nope. 82 divided by 7. No. Okay, so we're most likely just going to leave it at this. Yeah. So anyways, 4. So what I wanted to get at was we have a square root of 328 equals square root of 4 times the square root of 82. This is equal to the same thing. Okay. Then we can break this down. So 328 would equal, we know the square root of 4 is 2. 2 times the square root of 82. I don't think 82 can be broken down. I could be mistaken right now, but I do not think it can be broken down any further than that, right? So anyways, 2 times 82. So now we have 2 plus 2 times, right? This, let's get rid of this. So this now becomes, we have 2 options here. We have the positive side and we have the negative side. So the positive side is 2 plus the 2 times 82 all over 2, right? And then we have the negative side, which is 2 minus 2 over 82 all over 2. Now you can simplify this further down. Give us a decimal if you want. So let's go with 2 plus 2 times the square root of 82 divided by 2. Let's say I had to round it to 2 decimal places. I would get something along the lines of 10.06. And then the other one, I would have, let's say, 2 minus 2 to the square root of 82 divided by 2. So again, rounded to 2 decimal places, I get minus 8.006. All right, so this would be your final answer. Actually, no, I did a mistake here. So you go back, right? X would equal either this or this. We go back. We go back to our log. Our original, let's remove these underlines. Our original question right here. Can I have a log of a negative number? No, right? Because let's say I plugged in log of minus 6. It's going to give me an error. So we cannot have a negative number. So we're going to go all the way down here. And we're now going to cancel out this one. This one we cannot use at all. So we know now that our final answer has to be this one. And this is a rough estimate, of course. If not, if they ask you to keep it in a fraction, you can keep it like this too. This also works. All right, either or works. So this is our final answer. And this is why I said we're not going to go much more than this on this one. I actually realized I didn't use up any of the page. So I'm actually going to move this before I post it. But yes, that is how you solve logs with the same base.